So today we're going to be solving multivariable linear systems. Today the examples are going to be finding x, y, and z. Now, on this slide it has the steps that you can follow for solving three variable systems. This is what the book does. I'm going to do maybe a different variation of this. If you want to watch the videos that are in the book and follow the steps in the book, you can do that. But I'm going to do mine a little bit differently. So for this first system, most of the examples are going to have three equations with three variables. This one, the second equation, only has two. So that makes solving this system a little bit easier. So what I'm going to do is, my goal here is to usually add two equations at a time and eliminate the same variable from each. So notice my second equation, and I'm going to number these. So this will be equation 1, 2, and 3. Notice my second equation is missing the letter z. So what I'm going to do here is I'm going to combine equation 1 and 3. I'm going to add them together, and I'm going to eliminate z. However, in order to eliminate z, I need to multiply equation number 1 by positive 5, and I'm going to multiply equation number 3 by negative 3. And that will enable me to eliminate the letter z, and then I'm going to add that to equation 2. So x minus 2y plus 3z. I'm writing in equation 1, and I'm going to multiply it by 5. So this one I'm timesing by 5, and this one I'm going to be timesing by negative 3. So I'm going to distribute, and I get 5x minus 10y plus 15z equals 45. Now I'm going to multiply negative 3 to equation number 3, because my goal here is to eliminate the letter z in a new equation. So I'm going to distribute negative 3, and I get negative 6x plus 15y minus 15z equals negative 51. I'm using elimination here. I'm going to now eliminate the letter z. When I add the two equations together, I'm left with now negative x plus 5y equals negative 6. I'm now going to combine this with equation number 2, but I am going to multiply equation number 2 by negative 1. And I want to eliminate the x. So now I'm going to eliminate x. And the way that I can do that is take equation number 2, and I'm going to multiply it by negative 1. So negative 1 times negative x plus 3y equals negative 4. So this one I'm just writing down, the newly formed one. I'm going to take my equation number 2, distribute the negative 1. And now I can add the two equations together. Once I add them together, the x's cancel. I end up with 2y equals negative 2. Divide by 2. And I have the value of my first order pair, or my first number out of my ordered triple. Because when I'm done, I'm going to be finding x, y, and z. You're going to write it in the parentheses in alphabetical order. Now, once you find the value of the first variable, now we're going to go back up, and we're going to substitute it back in step by step. So now I'm going to take what I just found, y equals, and I can either plug it in to this left equation or to the right equation. It doesn't matter. You can choose, but it's the one step up where you have the two variables in it. So I'm going to go ahead and I'm going to plug it into Let's see, which one do I want to plug it into? I'm going to plug it into the left side. It doesn't matter. So I'm going to take negative x plus 5y equals negative 6. So this one right up here. I'm plugging in y equals negative 1. I'm going to multiply here. I'm going to move the 5 over. I get negative x equals negative 1. Divide both sides by negative 1, and x equals positive 1. I now have the value of my second variable. Now to find the last one, letter z, yes?
Couldn't you also use x minus 3y equals 4?
Absolutely. Yep. You can also use the original, yes. Absolutely. Now, so really what you're doing is plugging it into one of these. Absolutely. Now I'm going to take both of these and I'm going back to the beginning and plugging them in to get the letter z. I'm going to go ahead and plug it into the first one. X minus 2y plus 3z equals 9. I'm replacing x with 1, y with negative 1. I don't know z. I'm going to multiply here. Combine my like terms. Move the 3. Subtract here. Divide. And z equals 2. My ordered triple is the numbers 1, 2, and negative 1. Did I do that? No, I did that in the wrong order. Wait, back up. The y goes in the middle. 1, negative 1, positive 2. X, Y, Z. Now, most of the next examples have 3 equations with 3 variables. And this is going to be the process that we use. Pretty good on example 1? Let's try the next one. For the next one, again, I'm going to number my equations. This is equation 1, 2, and 3. Now, the first step, you decide which variable you want to eliminate. I look for things that's going to involve the least amount of work. So what I've decided that I'm going to eliminate first is going to be the letter Z. Because notice this, when I add equations 2 and 3 together, the Z's are going to automatically eliminate without multiplying by anything. Now your goal here is to pick what they call like a pivot row, or the row that you're going to use for both. So I'm going to do 2 different setups. I'm going to add 1 and 2 together, but in order to eliminate Z, I need to multiply equation number 2 by 6. But I can add equations 2 and 3 together without multiplying by anything. So notice they both have in common row 2. So I'm going to add 2 to 1 and 2 to 3, but in order to eliminate Z from adding the 1 and 2 together, I need to multiply equation 2 by 6. So let me take equation 2, and I'm multiplying by a 6, not a 2. So I'm multiplying equation 2 by 6. Equation 2 is 2x plus y minus z equals 2. Once I multiply, I get 12x plus 6y minus 6z equals 12. I'm adding that to number 1, so let me write equation number 1 underneath it. So all my x's, y's, and z's are lined up, and my constant. If you're ever given a problem that's not lined up, you need to fix it. So now I'm going to add them together. Once I add them, the z's cancel, and I'm left with 15x plus 15y equals 15. I'm now going to add 2 and 3 together to eliminate z. So I'm going to take 2x plus y minus z equals 2. X plus y plus z equals 2. I'm going to add them together. Again, the z's cancel out. I'm left with 3x plus 2y equals 4. I'm now going to work with what I'm used to seeing back from 9-2. I now have only 2 unknowns. So I need to decide which variable to eliminate. I need to multiply by something to get it to cancel. I think it's going to be easier to eliminate x, and I can multiply my equation on the right by -5. If I want to eliminate y, I would have to multiply both equations and make them both 30. So this is why it's going to be easier to eliminate x. So now I'm going to take and multiply this equation, and I end up with -15x minus 10y equals -20. I now can add my equations together, and now I'm left with the x's are gone, and I'm left with 5y equals -5. Divide by 5. Y equals -1. I now need to work backwards and go back up and plug it in to either the left side or the right side. I'm going to go ahead and plug it in to this one. My numbers are a little bit smaller. So 3x plus 2y equals 4. I'm plugging in -1 for the y. 3x minus 2 equals 4. Add the 2. 3x equals 6. Divide by 3. X equals 2. I now have the second number for my ordered triple. So again, you're going to take these two numbers and go back to the beginning and grab one of the original equations. I'm going to go ahead and to solve for z, I'm going to use the last one. Because look at the last one. It's just got a x plus y plus z equals 2. So that's the one I'm going to use. Again, you can choose. X plus y plus z equals 2. Take out x, replace it with a 2. Take out the y, replace it with -1. I don't know z. I'm going to add my like terms here. 2 minus 1 is 1. I'm going to subtract 1 from both sides. And z equals +1. My ordered triple in alphabetical order. X is 2, y is -1, and z is +1. And there's your ordered triple. That good? All right, let's go on. Again, let's take a look at our system and let's decide what we want to eliminate. This one's nice. Notice that I could eliminate y nice and easily by adding equation 1 and 2 and then 1 and 3. Notice the equation in common is equation 1. I don't need to multiply anything here. So equation 1, let me write it down, and then I'm going to put equation 2 right underneath it. Could rewrite the 1 and 3 also. And then I'll add them. So equation 1, equation 3. So when we do this, we're eliminating, y. So what we're eliminating here to begin with, we're going to get rid of the y out of both equations. So now I can add 1 and 2, and I end up with x, the y's are gone, plus 2z equals 10. Gonna add 1 and 3, I get 5x, the y's are gone, plus 2z equals 18. I now need to work with these two equations, and this is the same thing we did in 9-2. You can choose, do you want to eliminate x or do you want to eliminate z? I'm going to eliminate z because I can get away with multiplying one of my equations just by a -1. You could eliminate x and you could eliminate that, multiply that left side by a -5. So I'm going to multiply this one by -1. So I'm going to go ahead and write the right one down first. So I just wrote that one down, and now I'm going to put this one underneath. -x minus 2z equals -10. I can add the two equations together. I get 4x, the z's are gone, equals 8. Divide by 4, x equals 2. I've got the value of my first variable for my ordered triple. I trickle back up. I'm going to plug it into either the left or the right side. I'm going to plug it in over here. Looks like it's going to be the least amount of work. I don't have to multiply x by anything. So x plus 2z equals 10. This is where I'm plugging in x. 2 plus 2z equals 10. Subtract 2. 2z equals 8. Divide by 2. And z equals 4. I now have two of my variables. I'm going to take both of them and put it up at the beginning. I'm going to go ahead and plug it in. I'm going to plug it into the middle one. Again, it doesn't matter. So my middle equation, -x minus y plus z equals 1. My x is 2. I don't know why. My z is 4. I'm going to combine these like terms. 2 minus y equals 1. Move the 2. -y equals -1. Divide both sides by -1. And y equals +1. So my ordered triple in alphabetical order, 2, 1, 4. Let's try example 4. So again, let's take a look and let's see what might be the easiest to eliminate. I am going to eliminate x. I'm going to get away with multiplying this one by -2 and this one by -2. So I'm going to add 1 and 2 together, but I'm multiplying equation number 1 by -2, and then I'm going to multiply or add 2 and 3 together, but I'm multiplying equation number 3 by -2 as well. So let me go ahead and write down -2, and then x minus 3y plus z equals 1. I'm going to distribute. I'm going to write equation number 2 right below it. And now I can add them together. The x's cancel out. I get 5y minus 4z equals 0. I'm now going to write down equation number 2. Actually, let me do number 3 first. I'm going to do negative 2 times equation number 3 equals negative 1. So I'll distribute. And then now I'll write equation number 2 right underneath it. So 2x minus y minus 2z equals 2. My x's cancel out. I'm left with negative 5y plus 4z equals 4. I now have something that looks like what we did in 9-2. Notice when I add these together, both my y and my z are going to cancel. So if I take these and line them up, 5y minus 4z equals 0, and then put the 1 underneath it. Notice you're left with nonsense, because these all cancel out. You're left with 0 on the left. When this happens, you stop, and it's no solution. Let's see if we can get the next one, which will be infinitely many. Pretty good here. All right, next one. Now this one's sort of similar to the beginning. I need to work with equations 1 and 3, and I need to eliminate x because that's what's missing from equation 2. And we are here for another 5 minutes. Okay, so what I'm going to do to eliminate, all I have to do is add them together. I know this is hard to see, but there's a little negative sign there. I know there's a dot next to it. So I'm just going to add 1 and 3 together. And I end up getting x plus y minus 3z equals negative 1. And then I'm going to add that to negative x plus 2y equals positive 1. The x's cancel. I'm left with 3y minus 3z equals 0. And now I can add that to equation number 2. But I need to multiply equation number 2 by a negative 3.
Wait, why don't you need to add anything to equation number 2?
Because we already eliminated the variable that equation 2 doesn't have. Now, we could have also probably combined the other one and then combined it with 3, but this is the way we're going to do it. So let me go ahead and distribute. And once I distribute this, notice when I add them together, I get 0 equals 0, which is a true statement. So when everything cancels out, this is going to be infinitely many solutions. Because it doesn't matter what you plug in, it's always going to give you a true statement. Let's try numbers 6 and 7. Let's see if we can get there. So number 6, I'm going to go ahead and look at my equations and decide what is going to be my best option. It's looking like maybe I want to eliminate z. Because notice when I add equations 2 and 3, the z's are already going to cancel out. So the only thing I need to do is when I add 1 and 2 together, I'm going to multiply my first equation by a 2. But when I add 2 and 3 together, I don't have to multiply anything. So let me take equation 1. I'm going to distribute it 2. And again, you could have picked a different letter. Like if you wanted to eliminate x, you'd have to multiply equations 1 and 2 by -3. Again, you can choose. So when you go to take this test, it's going to be very, very, very important that you show work. So 2x minus 2y plus 2z equals 8. I'm now going to add that to 2. Once I add it to 2, the z's cancel out. I'm left with 3x plus y equals 5. Let me go ahead and add 2 and 3 together. X plus 3y minus 2z equals -3. Adding that to equation number 3. 2y, 2z equals 6. Again, the z's cancel out. And I'm left with 4x plus 5y equals 3. I now have the same scenario I did with 9-2. I have to decide which variable to cancel. I am going to cancel y. I'm going to multiply this equation by a -5. So this will become -15x minus 5y equals -25. Bring this one down. Add them up. The y's cancel, and x is equal to -11x minus or -22. Divide by -11. X equals 2. Remember, now we work back upward. So I'm going to plug it into either the left or the right. You choose. I'm going to go ahead and plug it into the left side. So 3x plus y equals 5. I'm plugging in x equals 2. This time I'm solving for y. Subtract 6. And y equals -1. Now that you have the value of 2 of your variables, we're going back to the beginning and we're going to plug in and solve for z. I'm going to go ahead and choose the first equation, x minus y plus z equals 4. I'm plugging in 2. Y is -1, but remember it's got that subtraction sign. And then again, you're solving for z. So 2 plus 1 plus z equals 4. 3 plus z equals 4. Subtract 3. And z equals 1. My ordered triple, 2, -1, +1. One last example, and we are done. So for the last one, again, let's take a look to see what can we get away with possibly not multiplying a lot of things. I think I'm going to go ahead and eliminate x. So I'm going to multiply my first equation by -3. So this is 1, 2, 3. So let me go ahead. I'm going to multiply equation number 1 by 3. And then I'm going to add that to 2. And then I'm going to take equation number 3. And I'm going to multiply that by, actually I'm going to eliminate y. So then I'm going to multiply equation number 3 by 6. And this is the equation numbers. And I'm going to add that to equation number 2. So equation number 1, when I multiply it by -3, x minus 2y plus z equals 4. Distribute the -3. And then over here, I'm going to distribute a 6 to equation number 3. I get 12x plus 6y plus 24z equals 12. So let's go ahead and try the first one. I'm going to write equation number 2 underneath it. 3x minus 6y plus 3z equals 7. Notice that my x's cancel, my y's, my z's, and now I'm left with -5. Soon as you first start, if you get nonsense, 0 equals -5, which will never occur, you stop, and the answer is no solution. So I didn't even need to bother doing this if I would have taken the time to just go through and add equations 1 and 2 after I multiplied equation 1 by -3. So that is it for the examples on section 9.3. Remember to complete these notes and submit them to Canvas before 8 a.m. on Monday. Have a great weekend.